He kōna I purangi tēnei nā te reo irirangi o Aotearoa.
Kia ora and a very warm chemical welcome to Elemental from RNZ. I'm Alison Balance.
And I'm Allan Blackman from the Auckland University of Technology. And we are striding boldly through the S's in our alphabetical stroll through the periodic table, which brings us in episode 73 to Scandium.
Scandium, scandal. I wonder if we can find anything scandalous to say about this element, which sadly falls once more in the terribly sorry but I've never heard of it basket.
Scandals, huh? Okay, well, I'll see what I can do to oblige. But sadly, and rather uninterestingly, the name Scandium has nothing in common with the derivation of the word scandal, and rather it comes from Scandia, which is the Latin for Scandinavia. And how did it get that name? Well, it was originally detected in and isolated from the mineral euxenite.
Can you just spell that for me, please?
Yeah, I can try. Euxenite, euxenite.
Of course, thank you.
This was discovered by the Swede Lars Fredrik Nilsson. He thought that this particular mineral only existed in Scandinavia, and hence the name. So this was in the year 1879, and so this made scandium the second element to be found out of the elements that Mendeleev had predicted in 1869 when he came up with his original periodic table. So within just 10 years, two of his predicted elements had come to pass, and people were increasingly confident that he knew what he was talking about.
I think he did know what he was talking about. By the way, he gave placeholder names for these elements. What was the placeholder name he gave to what became scandium?
He had a funny sort of naming system. He would preface an element name with Eka, E-K-A, and then insert the element that this missing one was meant to resemble. And so in scandium's case, he called it Eka boron, because it was meant to resemble the chemistry of boron, which is kind of interesting with what we know nowadays, because boron is in group 13, but scandium is in group 3. They're in different groups of the periodic table, but yet they do behave a little bit chemically similarly, and this is all due to d electrons in scandium, which boron doesn't have. But if you want to know any more about that, come along to my first year classes and I'll tell you all about it. So, there we go, a very long-winded way of answering that question. Eka boron, it's a name that has long dropped to complete obscurity, except in podcasts like this one.
Oh, we've got to be good for something.
Absolutely. Okay, so down to business. The vital statistics, the elemental symbol SC, and the atomic number 21, which, as I alluded to before, that puts it in group 3 of the periodic table over towards the left-hand side, and indeed makes it the first of the transition metals. And these are elements which have got partially filled d orbitals. We're talking about d electrons here. And most of the first row transition metals, at least, I'm sure many listeners will be familiar with, so things like iron and manganese and copper. Scandium, certainly nowhere near as well known as its transition metal neighbours. So what do we know about it? Well, the metal itself has roughly the same density as aluminium, and that means it's not very dense, but the beauty of it is that it's got a much higher melting point, and it's also very, very strong.
Does this mean that you can put it to the same kind of uses that you can put aluminium to?
Well, if there was lots of scandium around, yes, you could, but it's really too expensive and rare to do anything with on its own. However, if you go and alloy it with different metals, then the particular properties of scandium means that it's going to impart those good properties to the alloy. So you can make an alloy of scandium with aluminium, and which involves only around about 0.1 to 0.5% of added scandium, and that gives you a product that is lightweight and it's strong and it's got a melting point that means it can be welded, which you can't actually do with pure aluminium. Indeed, addition of that tiny percentage of scandium almost doubles the melting point, which is quite remarkable.
Oh, that's doing a lot with a little, isn't it?
Oh, yes, indeed. So, scandium adds strength, I guess, and indeed it was rumoured that scandium was used in the nose cones of Soviet ICBMs, intercontinental ballistic missiles, from those of you who remember the Cold War, carried in submarines, and so that they could actually punch through the ice once they were shot out of the sub.
Really?
Well, yeah, maybe, but don't believe everything you read on the internet. That one came from Google. But this isn't Scandium's only Soviet military use, though. So most definitely a Scandium aluminium alloy has also been used in Russian MiG fighters. And more prosaically, perhaps, you can also make very, very high-end bike frames from this alloy as well. Again, light and strong. Which is also, sadly, the reason it's probably used in some gun bodies as well. And really, there's not too much else to say.
You really haven't been very good at digging up any scandals for me then.
Okay, so here's the best that I can do, and this involves the greatest sport on the planet, which is, of course, cricket, before you ask.
Yawn. Oh, sorry, carry on, carry on.
So those of you with long memories might remember Dennis Lilly's aluminium cricket bat that he briefly wielded at the Wacker in 1979 against England. And that was, in fact, rumoured to be one of those Scandium aluminium alloys. It had a little bit of Scandium in it. That's what we think, although actually it's very, very difficult to confirm. But let's not ruin a good story for the sake of the truth. So basically, day 2 of the test, Lilly came out with a newfangled aluminium bat called the Combat.
Oh, nice name.
I know, very, very cute. And he was whacking away with it quite successfully when the English began complaining, and even his own teammates weren't happy, and he was basically presented with a willow bat and told to go back to using it. I don't think the Brits were too thrilled about the whole aluminium bat because they reckoned it was wrecking the ball.
Because it's not cricket.
It's just not cricket.
It's just not cricket.
And so as a result of this, very, very soon after, the scandalised cricket authorities amended the laws of cricket, no less, to state that the blade of the bat was to be made of wood. And you'll find this in Law 5.
Hear, hear.
So an interesting fact for you that's sort of tangentially related to cricket. One Scandium compound that does have some use is a thing called Scandium iodide with the chemical formula SCI3. And that is used in mercury vapour lights to give a near sunlight colour. And that's extremely useful when you're filming indoors or when you're filming at night. For example, those night matches where the cricket players are now all sportingly playing with wooden cricket bats.
Oh, nicely tied up together there, Alan. Nighttime cricket tests, eh? It's wonderful what strange alleys this podcast takes us down at times. You can check out all the previous chemical highways and byways that we've travelled down at rnz.co.nz/chemistry.
And they are also all preserved for posterity on the elemental feed of any podcast app you might like to use.
We're back next time with selenium, but until then, it's bye from me, Alison Balance.
And cheerio from me, Allan Blackman. Mā te wā.